So hello everyone, welcome to this new video. So in my previous video I had started with module 3, right, Laplace transform. So I've given you some of the brief introduction about the definition of Laplace transform, its uniqueness, existence, and I've also discussed some of the Laplace transform of some elementary functions, okay, which are very important. I've discussed some 7 functions starting from Laplace transform of 1, Laplace transform of t to the power n, Laplace transform of e to the power at, then sine cos functions along with the sine hyperbolic and cos hyperbolic functions. Okay, so I've discussed each of them in a detailed manner. So that video is available just previous to this video. Please, those who are new to this video, please go and watch that video, because I want you all to watch the video from the starting of this module, because if you understood each and every concept very clearly, then only you could be scoring good marks in this module. Okay, this is a very important module. So in this video we are going to start with the properties of Laplace transform. Okay, so the first property is linearity property. Okay, this is the first property. Let us see what this linearity property says. If a comma b be any constants of f comma g and f comma g be any two functions of the t, then the linearity property according to this, it is given by Laplace transform of a into f of t plus b into g of t is given by a into separate Laplace transform. That is, from here you take a common because it is a constant, so I have taken it a common here, Laplace transform of f of t, plus again from here you take b common outside into Laplace transform of g of t. Okay, first what you do, multiply, then after multiplying take the constants common outside and do it separately. Okay, so this, the linearity property suggests this value. Okay, so let us try to prove it. Let us see what we would be getting after proving this part. That is, by definition of Laplace transform, this is the definition. In place of f of t, now we are having a into f of t plus b into g of t. Okay, so write that. After that, multiply, that is e to the power minus st into a into f of t plus e to the power minus st into b into g of t dt. Okay, after that do the separate integration here. After doing the separate integration, you could take the constants outside here, a as well as b, then we are left with these two integration. So here if you observe here, as a into 0 to infinity e to the power minus st f of t dt. So this part here is simply, we could say, in place of this you could be writing Laplace transform of f of t according to the definition. Okay, so here also in place of f of t what we are having g of t, so that's why this would be becoming the Laplace transform of g of t. Okay, so like this we would be proving this linearity property. Okay, so hope you understood this linearity property. So now if you didn't understand while solving the problem, I guarantee you that you would be understanding it, okay, very carefully. So according with respect to this linearity property, now we are going to solve some problems, okay, very important ones. So let us start with the problems of this module now, starting from the linearity property. Okay, let us discuss some problems now. So this is the first question under linearity property, that is, find, they have given the question as find the Laplace transform, that is L, of sine 2t into sine 3t. Okay, so this is the first question they have given to find its Laplace transform. Okay, so let us try to find it now. First, here if you see, this is of the form sine A sine B, right? According to one trigonometric identity, this sine A sine B is given by 1 by 2 into cos of A minus B minus of cos of A plus B, right? So this is one trigonometric identity. In place of A we have 2t, in place of B we have 3t. So this is of the form sine A sine B if you observe here. Okay, first step that we should be simplifying this inner f of t part. Here f of t, what they have given, sine 2t sine 3t. Okay, according to this, now do the necessary changes in the question. That is, f of t now it would be equal to 1 by 2 cos of a minus b, that is 2t minus 3t minus cos of a plus b, that is 2t plus 3t, right? So solve this. After solving you would be getting cos of minus t minus cos 2t plus 3t is 5t. Okay, cos of we also know that cos of minus theta is equal to cos theta itself, right? So we would be getting this as cos of minus t is cos t itself. So I am multiplying 2 to this both terms, so we are going to get cos t by 2 minus cos 5t by 2. Okay, so this is our new f of t after simplifying. Okay, now this we should be using in this Laplace transform. We should be taking this Laplace transform, and let us see what we would be getting. Now Laplace transform of sin 2t into sin 3t is given by Laplace transform of this term, that is cos t by 2 minus cos 5t by 2, right? Now let us see what we will be getting. So here, first step what I am doing is, according to the linearity property now, here if you take 2 is as common denominator, so we could be taking 1 by 2 common since it is a constant. Okay, so take it outside and we are left with Laplace transform of cos t plus of minus cos 5t. Okay, I am just applying the linearity property here. Okay, according to that, here what I have done it, I have taken constant outside and I have grouped the remaining terms. So 1 by 2. Now what I am doing, I am taking this Laplace transform, I am multiplying it with both the separate terms. That is, I am taking the separate Laplace transform of Laplace transform of cos t plus Laplace transform of minus cos 5t. Okay, so now you would be getting 1 by 2 into Laplace transform of cos t, or minus you put it outside here, so we would be left with Laplace transform of cos 5t. Okay, like this we have simplified here. Now what I am doing is, according to the fifth elementary function which you have discussed here, if you observe here, I have discussed according to the fifth elementary function, Laplace transform of cos at is equal to s divided by s square plus a square. Okay, where in place of a we are having here 1 as 1, in place of a once we are having 1, and here we are having 5. Okay, according to that let us substitute. Now I'll write it here. Since Laplace transform of cos at is equal to s divided by s square plus a square, so according to this now I'm going to change it here, that is (1 by 2) into s divided by s square plus a square. Now in place of a what we are having, coefficient of t is 1, okay, plus 1 square minus s divided by s square plus, in place of a we are having 5. Okay, so s divided by s square plus 5 square. So now you simplify it and just do the mathematical simplification and see what you are getting. So this is s divided by s square plus 1 minus s divided by s square plus 5 square is 25. Okay, so 1 by 2. So now do the cross multiplication and multiply the denominator. So s into s square plus 25 minus s into s square plus 1 divided by s square plus 1 into s square plus 25, that is equal to 1 by 2 into s into s square is s cube plus 25s minus s cube and 1 into s, that is minus s. Okay, divided by s square plus 1 s square plus 25. So here s cube and minus s cube would be getting cancelled. So we are left with 25s minus s, that is equal to 24s divided by s square plus 1 into s square plus 25. Okay, so 2 ones are 2 12s are, so our final answer is 12s divided by s square plus 1 into s square plus 25. As I've told you, right, Laplace transform of f of t would be of the form, would be in the f of s, right? The function would be completely in terms of s. So if you observe here, we have solved for sine 2t plus sine 3t here. Since according to the definition, L of f of t is equal to f of s, right? The final answer you would be getting in terms of s variable here. So if you observe here, this is f of s, that is 12s divided by s square plus 1 into s square plus 25. Okay, so this is the problem, guys. So please note it down and try to understand it. Okay, so let us see with the next question. So this is the next question, guys. Find Laplace transform of the given the function sine cube 2t. Okay, so here if you observe, this is of the form sine cube theta. Okay, so according to one trigonometric function, sine cube theta is given by 3 sine theta minus sine 3 theta divided by 4. Okay, so in this way the sine cube theta is represented generally. So in place of theta, what we are having here, 2t. So let us first simplify that. F of t, in place of f of t, what we are having, sine cube 2t. Okay, that is equal to, in according to this, 3 sine 2t minus sine 3 into 2t, that is 60. Okay, divided by 4. So now what I am doing, I am taking dividing 4 separately. So we will be getting finally our f of t is equal to 3 sine 2t divided by 4 minus sine 6t divided by 4. Okay, so this is our new value of f of t now. Okay, after simplifying this in this way. So now for this we should be applying the Laplace transform, that is L of f of t. Okay, that is equal to L of 3 sine 2t by 4 minus sine 6t by 4. Again here 1 by 4 you can take it common outside here. And here 3 sine 2t we are left. Apply the linearity property, plus of minus sine 60, right? So here now what I am doing is, as previously I am doing, I am taking Laplace transform for these two functions separately. Okay, that is Laplace transform of 3 sine 2t plus Laplace transform of minus sine 60. Okay, so now here 1 by 4, here we have 3 sine 2t. Okay, if you observe here, this 3 is a constant. Okay, it is a. So according to linearity property, you should be taking this constant outside, right? So we are left with 1 by 4 into 3 times L and the function, other function as it is, that is sine 2t, plus here also, here we have minus 1, you take it constant outside, so minus L sine 60. Okay, now according to the fourth elementary function which I have discussed, that is Laplace transform of sine 80 is given by a divided by s square plus a square, right? So this we are going to apply it here now for sine 2t as well as sine 60. In place of a we are having 2 and 6. So since Laplace transform of sine 80 is equal to a divided by s square plus a square, so this would be becoming 1 by 4, 3 into a. In place of a we are having 2 here, divided by s square plus 2 square, that is 4, minus, in place of a we are having 6 divided by s square plus 6 square, that is 36. Okay, now solve it. 1 by 4 into 3 2s are 6 divided by s square plus 4 minus 6 divided by s square plus 36. Take the LCM, do the cross multiplication and multiply the denominators. So 6 into s square plus 36 minus 6 into s square plus 4 divided by s square plus 4 into s square plus 36. So 1 by 4 into multiply 6x square plus 36 into 6. If you solve it, you will be getting 36 into 6 is 216. Okay, minus 6x square minus 6 into plus 4, that is minus 24. Okay, divided by s square plus 4 s square plus 36. So 6x square minus 6x square gets cancelled. So 1 by 4 into 216 minus 24, that is equal to 192 divided by s square plus 4 into s square plus 36. So 4 ones are 4, 48 times are 192. Okay, you can check it. 48 into 4 is 192. Okay, so now our final answer we get is f of s is equal to 48 divided by s square plus 4 into s square plus 36. Okay, so this is our final answer, guys, for this problem, sine cube 2t. Okay, we have taken the Laplace transform, and in terms of s domain we have got this answer, that is 48 divided by s square plus 4 into s square plus 36. Okay, so please note it down. We have one more problem, let us solve it. So this is the next question, guys. Find Laplace transform of cos square 2t. Okay, so here again this is of the form cos square theta. Okay, and according to one trigonometric identity, cos square theta is given by 1 plus cos 2 theta divided by 2. Okay, yeah, and you also don't know sine square theta also, it is given by 1 minus cos 2 theta by 2. Just for the case those don't know, I have written these two formulas. We should be knowing these trigonometric identities. Okay, so now let us solve f of t cos square 2t. Okay, so that is equal to 1 plus cos 2 theta, that is theta, in place of theta we are having 2t, so 2 into 2t is 4t, so 1 plus cos 4t divided by 2. So our f of t would be equal to, separately divide 2 for both the terms, so that is 1 by 2 plus cos 4t by 2. Okay, so this is our new value of f of t. So now for this you should be applying the Laplace transform, that is L of f of t is equal to L of 1 by 2 plus cos 4t by 2. Okay, so now again 1 by 2 is common, right? Take it outside. We are left with 1 plus cos 4t, so that is equal to, now put the Laplace transform for these two terms separately here according to the linearity property. So L of 1 plus L of cos 4t, right? So according to the elementary functions we have Laplace transform of 1 and Laplace transform of cos 4t. So Laplace transform of 1 is given by 1 by s, right? So that I am substituting here, 1 by 2 into 1 by s plus Laplace transform of cos at is given by s divided by s square plus a square, right? For cos at. So according to this here, in place of a we are having 4, so s divided by s square plus 4 square is 16. Okay, so nothing much to do now, just simplify, cross multiply s square plus 16 plus s square divided by s into s square plus 16. 1 by 2 into s square plus s square is 2s square plus 16 divided by s into s square plus 16. So here in the numerator here we can take 2 common, so 1 by 2 into s square plus 8 remains divided by s into s square plus 16. So your 2 will be getting cancelled. So our final answer is f of s is equal to s square plus 8 divided by s into s square plus 60. Okay, so this is our final answer for f of s. Okay, so this is the problem, guys. Note it down. So yeah, we have discussed one important property, that is the linearity property, which is the first property of many properties which are going to come of the Laplace transform. Okay, so yeah, this was the video, guys. Hope you understood something from this video. We have solved 3 very important problems. So please don't skip any part of the video. Watch till the end. And if you understood something and you could like this video, so share this kind of videos to a huge number with your friends, family members, relatives, anybody, to whomsoever you matter. Okay. So that's all, guys. We'll see you in the next video. Thank you.